Okay, so we're going to be going over a game theory question. I'll explain the story and then we'll get right into the math. So there's two banks, ABC and XYZ. Each of these banks give the same amount of loan with an interest rate. So loan is D, and the interest rate is either R of 1 or R of 2, depending if it's ABC or XYZ. The number of people interested in the loan is N of 1 or N of 2, again, depending if you're ABC or XYZ. And you'll see that these are mirrored. So they're quite similar. So we're going to be finding our R1 star, R2 star, R star equilibrium. And this is the profit for one person. So it's profit of 1 equals R1 D1. That's for one person. So now we need to think in terms of N people, because we need to find the greater picture here. So that'll be our profit function. I'm going to do it for firm ABC. That's N1, R1, D1. It's all multiplied. It's all multiplied. So now we gotta put that all together. We know that N1 is equal to alpha less theta R1 plus R2. And that is bracket R1 D1. Okay, so this is your profit function for firm 1. Now we're going to do a partial derivative on bracket D1. So it's probably easier to look at it like this. So we have our initial story, two banks, loan, interest rate, number of people interested in the loan. We have our profit function for one person. So N drops to 1 or raises to 1 depending on the original number, but that's the story so far. Theta is at larger than 0.5 and alpha is larger than 0. So when we're interested in seeing what would happen if there was N1 people, then it's N1 times R1 times D1. That's your new profit function. And so we know that N1 equals alpha less theta R1 plus R2. So I just factored in R1, so it's really easy to see. Then you do your partial derivative with respect to R1, and then you make R1 equal R2 equal R star. You isolate R star, and this, right down here, is your Nash equilibrium, where R1 equals R2 equals R star equals alpha over 2 theta less 1. So that's part 1 done. Now we get to the fun part. So this is going to be your best response function right here. This is not the same as a Nash equilibrium. This is helpful for plotting on a diagram and then finding your Nash equilibrium at the middle. So this is not the same as an NE. A best response function is not the same as an NE, but it serves a similar purpose. So this is how I found it. This looks familiar. This is just our first order condition. We're getting rid of D1. This time we don't care that R1 equals R2 equals R star, because we're not trying to find Nash equilibrium. We're trying to find the best response function. There's a goddamn difference. Come on. Okay. Sorry. This was positive. I don't know why I made that negative. That's my bad. I was right. I was right when I did my math. I wasn't right when I... You know what? Because it's correct, I'm putting a little box around it. Okay? Now you know. So look at that. And it looks exactly like our answer when we did it with real life math. So there's a great way of doing this. to make plotting easier, you can separate some terms, okay? So R1 equals theta over 2, oh my gosh, alpha over 2 theta, plus R2 over 2 theta, okay? Boom. And this makes it easier to plot, right? Because when R2 goes to 0, then you're just left with alpha over 2 theta. So look, we know, guys, we know this. When theta is positive, which it always is, it's always greater than half, and alpha is positive, what do you think this means? The graph is going to look like this. Let's graph this out. Let's start, I'm going to put R2 down here, and I'm going to put R1 up here. Actually, does that make sense? I want to put R2. Nah, that makes sense. I've decided so. Okay. So R1 and R2, okay? When R2 goes to 0, R1 is at some positive alpha over 2 theta. And when R1 goes to 0, R2 goes to the exact same thing. And it continues to increase, okay? So we're going to draw that out. Look at that. Look at this go up. And this is also going to be going up. Okay? So this middle point right here, this middle point is our Nash equilibrium. We found it. We found it using our best response function. Look at that, guys. Wow. And this is the same for R1 equals R2 equals R star. Okay? That's your NE. I'm going to put NE there so everyone knows. Just a little recap. Ladies and gentlemen, just a little recap. We found our best response function. We did it by doing the partial derivative with respect to R1 because it's symmetric. You can do it with R2 if you'd like. You're going to get the same stuff, okay? But this time you don't combine the R's because you care about just the one firm and where it is going to end up, okay? So this time you just isolate for R1 and you keep R2 as R2 and you find out that it's alpha plus R2 all over 2 theta. And then you can separate the terms so it's easier to plot them on a graph. And on this graph, you find your Nash equilibrium anyways, which is alpha over 2 theta less 1, which we already found in the previous question. Am I right or am I absolutely tweaking? That's enough game theory for today. We're going to do more game theory tomorrow. So everyone, hold your horses. It's going to be more game theory coming up.